Alright, let's do a few more of these dark yellows, I think. And, but maybe not all of them. I'm going to mix things up a bit. Maybe do a couple and then go over somewhere else. Chimney. So there's an H up there. We can't split in this one. No splitting, so it's just a case of sticking to stuff in the right order. Well, almost certainly the shape will be like this, right? Well, no, because something has to go up there. So the O is going to go up there. So then you have to get out of the way somehow. Well, I could grab you, and then do this. Ah, close. There we go. Bis. Oh, okay. I was gonna say Bishy, but no, it's Bis. Hydroxylamine. Sure. Bis is Latin for twice. Okay, I see. I can't quite remember what hydroxylamine looked like, but cool. Maybe it's just with one. I don't know. Scoop. So you and those. Well, we definitely don't want to connect those ever. So we have to do this. There's no other starting move except like to go walk around here, but so we have to do that. And we need to grab one from the bottom at some point. We can never push those together. Okay, so one of them has to stay up and we have to like push down to get under the other one. How can we do that? How can we get one of them out of the way? The only one I can get out of the way without joining to another one is... Well, I know, I can join to another one. There we go, that's what I wanted to do. Cool. Methane. Methane can explode or suffocate people without warning. Lovely. Let's do one more. Heart. So... Right, you've got 3 bonds left. You're already bonded. That's interesting. No matter which way I try and do this. No, this is fine. This is fine. Cool. Earthquakes can release methane into the ocean from undersea reserves. Okay, let's unlock the next area here, and then we'll move on to a different thing. Factory. Ooh, this looks like an earlier one, but that was one of the cutting ones. So probably, I mean, definitely these are going to be connected, and then the others are going to be connected too. If we do that, then we're stuck. So. Being too wide's okay. If only I could get you. Could I have got you earlier? Can I make a shape to go in and get you? Not easily. Although it's suggesting to me, the shape of this is suggesting to me that I want to nudge one of them like that. The fact that there's that space up there, I can't see any, because I couldn't go between them and grab one from the top. But if that's the case, then I think it's going to be the other one. So that I can grab it with that. And before I do that, I need to have pushed the other one to the left, maybe? Because I could get out of here if I was the right shape. And then there, okay. So could I have pushed that left at some point? No, not really. I'm definitely going left or right. If I ever go up, then I'm either attaching there and I'm stuck, or I'm attaching there and I'm stuck, or I'm attaching there and I'm stuck. Unless, of course, I could get one of those in a good position. But to get them, to move them around, I have to attach to them. What about like this, and then push you over? This feels not terrible. Oh. Interesting. So I've connected to too many on one. One of those ones needs to be the other end. There. Oh, I've done it again. So which one am I going to connect you to? One of those two up there needs to be connected to you somehow. Yeah. And I don't think I can do that from this direction, unless I do... No, because I'm 3 tall. Right. How do I get you back up? It's symmetrical, so going right this way around is just the same. You need to attach to you, and then somehow... Maybe we can reach through the gap in the middle? No, I could never be that wide and then reach... Like the gaps at the side are too wide. But to reach through the space in the middle, it has to be 3 long. Plus stuff on the other side to 4, at least. So that's not right either. Oh, I can use this to nudge that. And then I can use that to nudge that up. Yeah, okay, that's the key thing here. Where exactly? Actually, maybe just there? Then I can do what I was doing already, which is something like this? No. How'd this work? This is slightly different to what I was doing before. Wait, so when I went round this way, I was doing this. What was I doing? Was it the vertical arrangement I was using? Yes, like this. Yeah, okay. With the vertical arrangement, I can't go and do anything about the other one. Whereas with this arrangement, I can do this, or I can push it up. Or I can do that. This is going to be hard to connect to these two. Let's do this. What if could I push you somewhere that, didn't mean to connect to you? I want to get you on top somehow. That's not on top. Although this is good. Cool. Hydrazine. Hydrazine has been used as a fuel for the US Army's liquid-propelled artillery. Okay, we've got that area. Oh, I see what this is doing. This is the shape of the periodic table, isn't it? Okay. I don't think this is the shape of the groups. I remember it being this weird looking. I don't know, maybe. Let's do some new mechanics, I guess. Green. Plus. What's that do? I guess we have to split over it again? Oh, it makes us a double bond. It gets rid of one of the numbers. That's great. Is that a covalent bond? Is that what a covalent bond is? The double line? I can't remember. Or is it the other way around? Ionic and... I don't know. Cations. Anions. Whatever. Carbon dioxide, CO2. The human body produces about 1 kilogram of carbon dioxide daily. That's a nice mechanic. It fits so well with the theme. It's great. So, we're gonna connect like this. Oh, I can't double that because H doesn't have an extra one. Okay, so we're doubling the ends. We're gonna connect the ends together, double that. And do, oh, we can triple it. Uh-oh. Diazine. Diazine is unstable. It'll react with itself. Oh dear. This is great. This is so good. So we must be doubling. If the C's shared a bond, they'd have 3 left. If they share again, they'd have 2 left. Oh, maybe this is just teaching that though, but still. I'd have to form a square, I guess. If that's what's happening here. But there's also nothing stopping me from doing this and attaching... Okay, this might be it. Attach like that. Then like that. Double this. Double that. Double that. Double them all. Okay. Ethylene dione. This molecule only lasts on average less than a millionth of a second before decaying. This is a cool mechanic. Okay, so H. Well, we can't double with the H. Oh no, this is going to get complicated. Gonna do some maths. What can connect to what? So the C is the most. It has to connect to 4 things. So C has to be surrounded, effectively, but it doesn't anymore because of the plus, which can be used as many times as you like. But it could be that it's surrounded and then... Well, not surrounded, but we just do this. But N needs to give up more stuff as well. This is gonna get complicated. I think the O and the N need to be attached to this. So you've got one left, you've got one left. But I can't double that. Double that. I think they need to be connected to the line, so HC and O double no. So it's actually a subtractor, even though it's a plus sign. It's subtracting the number of electrons left on both sides. You need to be connected 4 times, so we're definitely doubling a bond connected to this. But how can I fit the O in? Because I also need to get rid of 1 more in each of those. If I connect you 2 together, I can do that. What? How can this work? Oh, okay. I've been connected to the C every time, so maybe that's part of the problem. You could even connect straight to the O, and then not have to deal with the O anymore. And if we connect the O to the C, then it becomes 3, and then we just have to... Yes, okay. So this is fine to do. But that doesn't help me get there. Well, we could connect like this, and then like that. No. No, I need to be connected to the C, and then to that. Yes, this is exactly it. But how? Like this. Okay. Cyanic acid. Cyanic acid is very unstable and will explode above 0 degrees Celsius. Uh-oh. This group is a scary bunch of chemicals. Agoraphobia. So... Right, I mean this is the shape I want-ish. But to use that twice, I would need to be an L shape. Like, oh, how to set that L shape up? I want to be an L shape, like in this formation, I think. Definitely not that, because they both need to get rid of one still, and I could do it like that, but then can't connect to the C. I want to go under you, but yeah. That's impossible. Maybe there's another shape I can make? Like this doesn't let me get through it at all. Or maybe I... Wait, this does that shape. Okay. Carbon dioxide. Frozen carbon dioxide does not melt. It converts directly from solid to gas. That's what dry ice is, right? And then didn't somebody die like a couple of years ago because they threw dry ice in an indoor swimming pool, and then you know, it turned back into a gas, became just, you know, gas form of CO2, and the room basically just filled up with loads of CO2. And so even when they came above the water, there was no oxygen to breathe. Just CO2, and not everybody, but somebody like just suffocated. Don't mess about with dry ice. It's not very sensible. Lettuce. I'm gonna at some point have to come up with an actual way of thinking about this stuff. Right, because they... an actual way of thinking about this stuff. Because they just don't have anything to share. Like, they can't double up, ever. And we're already starting like this. There's 2 more H's. Probably I'm not connecting to them both straight away because that's like the obvious thing to do. So I have to squeeze out, but I have to connect to one of them. So where are the doublings going to happen? I guess they're going to happen between the C's and the O's. But the O's can't double up together, otherwise they'll just be their own little compound. So, if we do that, we have that problem. So basically I need those remaining 2 electrons to be on adjacent things. How? So therefore I can't leave the O's till last. I have to go past you at some point. I feel like I don't want to connect the C to the C. Okay, that's exactly what I'm doing. I'm doing something like this, aren't I? Maybe. still have the problem with that O needs to be connected to something. So maybe not that exactly, but I don't want to connect the C to the C for some reason that I don't fully understand yet. So I'm doing that. But then I can't connect to any of the others either, so we have to connect to that. So I need 2 free electrons on adjacent things. I have to connect either to the U or to U, and this is symmetric, so if I connect to U, you've got 3 left. So if you connect to one other thing, or if you connect to 2 other things, then I can only double up a connection to one other thing after that. So maybe I need to avoid connecting U. I think that might be it. Hold on. So if I do that and then connect to U, I can use this. And I can connect to U2 and do this. There we go. Whew. Acetic acid? Is that how you say it? Acetic acid tastes good on chips. It's vinegar. Delicious. Let's try blue. Rotate. Uh-oh. Is this going to rotate me somehow? Okay, so I rotate. I'm moving up there because I'm the dashed one. So we rotate around like this. Oh gosh. H2O, water's the main ingredient in milk, forests, and rainbows. Is it an ingredient in rainbows? I mean, I know it's part of the process, but I guess the rainbow is just a visual thing. Rainbow isn't really made of anything. Oh, it's the same shape as the previous level. But the previous one had a cutter in it. So I want to end up there with the O above, so like sorry, the O below. Clouds are made out of water that hasn't fallen from the sky yet. True. These facts are becoming strange. Right, I can't rotate that way because something hits the thing. That's bad. Oh, do I want to connect to... Now I want to connect on this side, so I can do this. Whoa, okay, it doesn't rotate us as a group. It's just those two that rotate. Oh my gosh, I don't know how I'll be able to think about that. Hydrogen peroxide, this chemical breaks down to water and oxygen. Makes sense, you lose an O. Becomes H2O and O. Oh my gosh. Okay, so we have to form a square, right? Yeah, this is now a snake game. Oh, once I've done that, I can't... Okay, so I have to connect them from behind. I think, so that I still have flexibility. And then somehow connect to that. That's not going to happen. Oh, but it's totally rotationally symmetric, so it has to happen at some point. Right, I can probably... No, if I do that I can't push. I want to slot down now. Oh, but if I get them in a snake, if I get that to join me... This, then can I do a snake and just wrap around? Yes, very nice. Tetraoxygen. Liquid oxygen contains traces of this unstable transient compound. This is such a neat game. Okay, so the rotations are on the wall now. So we're forming... Who? You're going to be in the middle at some point. Okay. Are you? Do you have to? Yeah, I mean, well, unless I can avoid connecting to one of you, which I can't. So we're going to have this problem. quite hard to visualize what a rotation will do. Like, it's easy if I like spend time thinking about it, but to plan actions around rotations, that's going to be pretty tricky. I can't see how much choice I have here. Except I have a choice to nudge you that way if I want to. Don't want that though, do I? Oh, I also could have nudged you. So maybe we nudge both. For whatever reason. Then we can use this as a rotation space. Or and this. I can't go up there. Oh, but I can do this, going backwards and do this. I want to connect and then bring you up. Yep. There we go. Hydrogen peroxide. If mixed with baking soda and salt, this can be used as toothpaste. Wonderful. Doesn't toothpaste have fluorine in it? Maybe feng shui. Let's go check out this grey area. Let's do a bunch of different stuff. Helium. Oh, helium. So you're just for pushing stuff around. Interesting. So I can't join onto those two, but we can do that. That's cool. NASA's helium balloons can float as high as 110,000 feet, 33 kilometers. Odd that the Imperial unit was used as the main one. T. Is it called T because it says T he? Oh no, maybe just because the shape of the level is a T. So we want to connect those to that. Okay, so this is going to be a case of how do I push them down without... Here we go, like this. Oop. Nice. Freedom. Oh, I am the helium. That was easy. Ionizing smoke alarms contain radioactive material which emits helium. That's reminded me I need to replace my smoke alarms. Pathways. I am again the helium. So we have to push you out of the way, bring you over here. Because these are going to have to go like this. How do we then put them back apart? Or, no, we can never push those together. We could never dip down that far. Huh, how do we pull you back up? Maybe do this. But how am I still can't pull that away from the wall ever. Now I can pull that away from the wall and I can go up. Yay. Helium. Near absolute zero, helium forms a superfluid, a liquid which climbs walls. Okay, these facts are becoming less factual. Against the wall. What is an actual superfluid? Is it like just super low friction or something? Superfluid. State of matter in which matter behaves like a fluid with zero viscosity. Flows without friction past any surface. So up a wall, of course. Let's do one more. Okay, so we need the end to connect. This is interesting, it's like a completely different feeling of a game. It feels different. Okay, I see the trick here. Is first get this one out of the way, then push that down. This feels more like Sokobond. Therefore it's quite easy to see the patterns that I need. Go. Some radioactive decay emits alpha particles, which are helium nuclei. Indeed, I was watching some lectures about that recently. Okay, this is cool. We've basically explored into all of the new colours. Presumably if I get that one, it'll open up a dark green area, although those two seem to be pointing towards like a turquoisey area, possibly? So that might be a new mechanic over there. Oh wait, but I've already finished that. Oh, do I have to finish two things to go that direction? Maybe. And then same here. Oh, so those will probably be the extra hard bits. And then there's a dark blue section I haven't unlocked yet. Okay, cool. We're going to keep exploring next time. Exploring the periodic table. Alright.